We're back with another set of problems from the solutions packet. These are on gravimetric analysis. This is a technique used to determine the concentration of an unknown solution through the use of an ion, which creates a precipitate with the ions in solution. By measuring the amount of precipitate created, we can use stoichiometry to determine the number of moles of solute and therefore the concentration of the original solution. In our first problem, we're told the amount of calcium chloride added to a specific amount of silver nitrate, and we're asked what is the mass in grams of silver chloride precipitate. Problem is we don't know if either of these is in excess, so we'll need to begin this with a limiting reactant analysis. My equation is calcium chloride reacts with silver nitrate to create calcium nitrate and silver chloride. We could also write a net ionic equation for this, which would be our silver ion plus our chloride ions react to produce silver chloride. So to find our limiting reactant, we could start with copper chloride, and it says that our concentration and volume are known. So the number of moles of calcium chloride is going to be equal to the molar concentration times the volume, just like we did in last section. 0.150 moles per liter of calcium chloride times 0.0300 liters. You'll note we changed milliliters to liters. And rather than solving the problem for the number of moles of calcium chloride, I introduce a stoichiometry ratio, 2 moles of silver chloride per 1 mole of calcium chloride. Canceling and solving, we have 9 times 10 to the minus 3 moles of silver chloride. We should do the same thing for silver nitrate. Beginning with the concentration in moles per liter of silver nitrate times the volume in liters, we now have the number of moles of silver nitrate. We then use a stoichiometric ratio, 2 moles of silver chloride per 2 moles of silver nitrate. Cancel, and we obtain 1.50 times 10 to the minus 3 moles of silver chloride. Okay, so we need to know which one is the limiting reactant and therefore which is the amount actually created. Our limiting reactant is silver nitrate. Therefore, 1.50 times 10 to the minus 3rd moles of silver chloride is the actual amount of silver chloride that's precipitated. We have one more step. The problem asks for the mass in grams of silver chloride. So we'll begin with our answer to the last problem and multiply it by the molar mass of silver chloride to get 0.215 grams of silver chloride. In the next problem, it's similar. It's stoichiometry and concentration combined. How many grams of sodium chloride are required to precipitate most of the silver ions from a solution of silver nitrate, a known amount, a known concentration. And it also says to write the net ionic equation for each reaction. Now, the reaction implied by this problem is sodium chloride plus silver nitrate reacts to create silver chloride plus sodium nitrate. We can use this equation, but we can also write a net ionic equation for this, which is silver ions plus chloride ions yield a silver chloride precipitate. We will again use N equals mv to determine the number of moles of silver nitrate that were in the solution. So I have the molarity of the solution times the amount in liters, and that gives me the number of moles of silver nitrate, 2.83 times 10 to the minus 3rd. The next step is to take the number of moles of silver nitrate and use it to determine how many grams of sodium chloride need to be reacted. So we'll start with stoichiometry, 1 mole of sodium chloride per 1 mole of silver nitrate. Now we're in moles of sodium chloride, so we multiply by the molar mass, 58.4 grams per mole. to get our final answer, 0.165 grams of sodium chloride. Okay, so this problem is a good example of finding the concentration of an unknown solution. And in this case, we want to know how much sulfate is in water, so we will add barium chloride to the water solution to precipitate the sulfate ion. It asks us to write the net ionic equation for this reaction, and then it also says we have a known volume of water. We're going to react it with excess barium chloride, and we're going to collect and measure the precipitate barium sulfate created and use this to determine the concentration of sulfate in the original water sample. So first we begin with the net ionic equation. The barium ion will react with the sulfate ion in the water to create barium sulfate, which is a solid. We use the number of moles of sulfate per liter of solution. So we need to find the number of moles of sulfate. We can begin with the mass of barium sulfate that precipitated out. That's 0.330 grams. And we're going to convert this to moles of sulfate ion. So I need the molar mass, 1 mole of barium sulfate over 233 grams of barium sulfate. And now this is in moles of barium sulfate. It asks about the concentration of sulfate. So we'll switch from barium sulfate to sulfate, and it's a 1-to-1 ratio, 1 mole of sulfate ions per 1 mole of barium sulfate. If we were to solve this problem at this point, we would have the number of moles of sulfate ion. Since molarity is number of moles over volume, we'll take that whole part and divide it by 0.145 liters. And canceling and solving, we get a molarity of 9.77 times 10 to the minus 3 molar concentration of sulfate ions.